Hello, everyone. This is Professor DePaulo. Welcome you back to Psych 220 Behavioral Statistics Lab. And I'm going to be talking about how to walk through the one-way analysis of variance, or the ANOVA. So the analysis of variance basically is when you have more than two conditions. So with two conditions, you have a t-test predominantly, right? With more than two conditions or three or more conditions, you have ANOVA. So you're not directly comparing the means like you do in the t-test, you are comparing the variances. The variance between groups, which is the variance between the three or more treatment conditions, compared to the variance within groups, which is the variance within all the treatment conditions added up, right, within each condition. So between groups is the effect of the treatment. Within groups is the individual differences within each group, right? Different people react differently to the same condition. And the goal is to have the between groups variance to be large and the within groups variance to be small. And that basically means that if the between groups variance is large, the means of the three conditions are separated by a greater distance. So you're kind of inversely looking at the means by examining the between groups variance. So if the between groups variance is large, the means are spread apart. If the between groups variance is small, the means are kind of clustered together. So you're not directly comparing the means, but you're using the variance, the between groups variance, to indirectly sort of understand where the means are. Now, if you reject the null is that all the means are the same of the three or more conditions. And the alternative is that all the means are not the same. If you reject the null and you support the alternative, then you have to go in and do the post-hoc tests to compare two conditions at a time and see if they are significantly different from each other. So if we rejected the null between three groups, we then go compare group 1 with group 2, group 1 with group 3, and then group 2 with group 3, and we do the two key post-hoc tests, and we determine which groups are significantly different from which other groups. And that's basically how the ANOVA takes place. And so we're going to be doing an example of ANOVA one way, which is one variable, one independent variable. And then we're going to be doing post-hoc tests using the Tukey. And in this example, we are looking at libido and sexual arousal in women. So this is an older study that looked at the role of Viagra in sexual arousal in women. And there were three conditions in this study. So one group was given 50 milligrams of Viagra, the second group was given 100 milligrams, and the third group was given a placebo. And then libido, or arousal, was measured on a 100-point scale. So the null here is that there's no difference between these three conditions. Basically, Viagra does not influence sexual arousal in women. The alternative is that there is a difference. So Viagra does influence sexual arousal in women. So this is our data here. Now, these groups are independent. So since these are independent groups, we have to put them in one column, one single column in SPSS. So if we go into SPSS, this is what we have. Sorry about these squares here. This is just an issue because I shrank the window and then I enlarged it. This is what it's going to look like, though. Here's libido. These are all three conditions in one column. Okay, so that's one variable. And I call that variable libido. Now I need to make a dummy variable because these are independent groups. So we have different people in each of the three groups. So I need a dummy column, a dummy variable, to then indicate which of these groups go with which of these conditions, right? So I can use 0, 1, and 2, or I can use 1, 2, or 3. It depends on what you want to do. There's no right or wrong answer. So I've used 1, 2, or 3 here. 1 being the 50 milligrams, 2 being the 100 milligrams, and 3 being the placebo. So I'm just going to do that here. So I'm going to have 10 ones. So all these people are in group 1, 50 milligrams. Then group 2, 100 milligrams, 10 people. And then group 3, placebo, the control group. And I'm going to call this treatment. You can call it whatever. You can call it group. Doesn't matter. Now I'm going to run the ANOVA. So analyze, compare means, one-way ANOVA. Treatment is our factor. That's the independent variable. Libido is our dependent variable. Right? I'm not going to look at effect size right now, and I'm not going to do any post-hoc tests yet. I don't do the post-hoc test until I know I have a significant one-way ANOVA. So hit OK. And as we can see here, there is a significant ANOVA. How do I write this up? So once again, go into Microsoft Word or whatever your word processing document is. F and the degrees of freedom. Now we have 2 degrees of freedom. We have a between groups degrees of freedom, which is the number of groups minus 1. And we have a within groups degrees of freedom, which is the total sample size minus the number of groups. So you're going to write both degrees of freedom, 2, 27, equals the F value, which is right here, 26.900, comma, and what is the significance? The P value? P is less than 0.001. So by looking at this, our P value here, which is less than 0.001, is tiny. That is less than 0.05, our traditional alpha value. So we reject the null here. And we say that all 3 groups are not the same, that there is a difference between all 3 groups. We don't know where that difference is, but that Viagra is influencing sexual arousal in women somewhere. We now need to do the post-hoc test once we reject the null here. So to do the post-hoc test, we're going to go back to the same menu, analyze, compare means, one-way ANOVA. We're going to go into post-hoc now that this is significant. If this was not significant, there's no reason to do post-hoc test because all the groups are the same, because that's the null. Go into post-hoc, find Tukey HSD, which is this Tukey right here on the top. Hit continue. These are all other post-hoc tests. Some of them I use. Some of them I have no clue what they are. I've never used them. Like a Hulchberg GT2. That sounds like a race car. I mean, I don't even know what that is. I've never used that before. So they all have benefits. The ones I use, they all have benefits and drawbacks. Tukey seems to be a pretty fair one. And it's pretty, I would say, in terms, it's not overly conservative in terms of rejecting the null. So I think it's a fair one to use to test post-hoc tests. That's my opinion. Hit continue. Hit OK. And these are our Tukey tests. So which groups are different? Well, there's 3 groups. So the number of groups, or the number of comparisons, let me write it down here. The number of comparisons for the post-hoc tests is n times n minus 1, right, divided by 2. Those are the number of comparisons for the post-hoc test. N times n minus 1 divided by 2. So n being the number of conditions. Well, there's 3 conditions. N minus 1 is 2. Divide by 2. That gives me a total of 3 comparisons. So there's 3 post-hoc tests I have to look at. Which ones are they? Well, we'll use A, B, and C, right? So it's, or 1, 2, and 3, since that's what we used. 1, comparison to 2, right? 1 and 3. And the other one is 2 and 3. Those are our 3 comparisons. And you see that here in SPSS. Whenever you see an asterisk, that means the comparison is significant at the 0.05 alpha value. So here, condition 1 and 2 is significant. So 1 and 2 is significant. Significant difference. So there's a difference there. What else? 1 and 3, is that significant? 1 and 3 is significant too. And then the other one we have is 2 and 3. So 1 and 2 is significant. 1 and 3 is significant. And then we have 2 and 3. And is that significant? It is not. So we're just looking at the asterisk here. 1 and 2, the asterisk. 1 and 3, no asterisk. Oh, 1 and 3, no asterisk. Whoops. Sorry about that. Not significant. And what about 2 and 3? 2 and 3, significant, 18.6. Right, so 2 of the 3 are actually significant. Which ones are not significant? Obviously 1 and 3. And that's it. So that tells me that 50 milligrams arousal is different than 100 milligrams. So let's look at the means. Shoot, we can look at the means here. Let's look at the means. Just go to descriptives and let's look at the means of libido. That's only giving me the overall mean. I got to look at the means by treatment. So let's do explore. Let's look at means of libido by treatment factor list. Just going to look at that. So the mean of libido of 1, which is 50 milligrams, is 51. The mean of 2, which is 100 milligrams, is 67. So that shows you that the 100 milligram dose led to much higher levels of libido than the 50 milligram dose. And then for the placebo, we get 49. So 49 is significantly less than the 100 milligram dose, but it's not significantly less than the 50, right? So what that tells you is that, you know, the 50 and the placebo are together, they don't really do much. And then the 100 milligrams is where you really get the difference. So the 100 milligram would be the advisable dosage if you wanted to increase libido in women based on this data. And that's the ANOVA. That's how we perform the ANOVA. Let's look at another problem. If we look at the other problem here at the end, we're looking at the divorce.save file. So we're going to go into a Porto or wherever you're at and open the divorce.save file. That should be in here somewhere. I just have to find it. File, open, data. And it doesn't look like I have it here. Let's look at the desktop. Sometimes things end up on the desktop. So I have the divorce save file here. Let's open that up. And let's look at, we're looking at ANOVA with post-hoc tests examining the effect of employment status, employ on life satisfaction. So employment status on life satisfaction. So analyze, compare means, one-way ANOVA. We want employment status on life satisfaction. So we got to find employ, which is right here. That's the factor. That's the between groups variable. And life satisfaction, we have to find life satisfaction here. right here, L-satisy, life satisfaction. Now let's just check for the significance of the ANOVA first. And when we check, we have a significant ANOVA here. F of 6, 222, that's a pretty big sample, right? Is 2.156. Is this less than 0.05? It is, barely, but it is less than 0.05. So we have a significant ANOVA. That means that there is a difference in life satisfaction depending on employment status. Where is that found? Need to do Tukey post-hoc tests. Analyze, compare means, one-way ANOVA. Let's do the Tukey post-hoc tests. Tukey on top here. Hit OK. And we have a lot of conditions. Why do we have a lot of conditions? Because there are 7 employment statuses, right? So let's go back here and look at that comparison again here. Before we had 3, let's look at 7. So if I have 7 groups, it's going to be 7 times 7 minus 6 divided by 2, which gives me 42 over 2. That gives me a whopping 21 comparisons to look at. Well, if there's 7 groups, it's group 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, 1 and 7. And then let's do for the 2s. 2 and 3, 2 and 4, 2 and 5, 2 and 6, 2 and 7. And now for the 3s. 3 and 4, 3 and 5. You see the pattern emerging here. 3 and 6, 3 and 7, then 4 and 5, 4 and 6, 4 and 7, and 5 and 6, 5 and 7, and then 6 and 7. So that should be my 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. This is 6 and 7, by the way. So those are my 21 comparisons. I use 1 through 7. There are the labels here. So what we want to do is not use the duplicates. So look for asterisks and don't use any duplicates. Which ones are significantly different? Asterisks by the significance value. And asterisks show significant difference. Well, actually, the asterisk would be in this column, the mean difference column. So look for the asterisk. What do we find? Right here. Unemployed and employed by another is significantly different, 0.028. And this one here, but this one's a duplicate because it's unemployed and employed by another. It's just switch the positions of those, right? So it's a duplicate. You don't want to list duplicates. So only one difference. Employed by another and unemployed. That's the only groups that are different from each other, and the rest of them are not significantly different. So you'd only list the difference, the one comparison. And that would be it for the ANOVA with the post-hoc tests. So hopefully that makes sense. And you get that. If you have any questions, let me know. If not, I'll see you for the next one, next lab, which will be on correlation regression. Bye for now.